The microscopic domain of physics deals with the constitution and structures of matter at the minute scale of atom and nuclei, and even lower scales of length, and their interaction with different probes such as electrons, photons, and other elementary particles. Classical physics is inadequate to handle this domain, and quantum theory is currently accepted as a proper framework for explaining microscopic phenomena. Overall, the edifice of physics is beautiful and imposing, and you will appreciate it more as you pursue the subject. You can now see that the scope of physics is truly vast. It covers a tremendous range of magnitude of physical quantities like length, mass, time, energy, etc. At one end, it studies phenomena at the very small scale of length, that is 10 to the power minus 14 meter or even less, involving electrons, protons, etc. At the other end, it deals with astronomical phenomena at the scale of galaxies or even the entire universe, whose extent is of the order of 10 to the power 26 meter. The two length scales differ by a factor of 10 to the power 40 or even more. The range of time scales can be obtained by dividing the length scale by the speed of light at 10 to the power minus 22 seconds to the 10 to the power 18 second. The range of masses goes from, say, 10 to the power minus 30 kg, mass of an electron, to 10 to the power 55 kg, mass of the known observable universe. Terrestrial phenomena lie somewhere in the middle of this range. Physics is exciting in many ways. To some people, the excitement comes from the elegance and the universality of the basic theories, from the fact that the few basic concepts in the law can explain phenomena covering a large range of magnitude of physical quantities. To some other, the challenge in carrying out imaginative new experiment to unblock or unlock the secret of nature, to verify or refute theories is thrilling. Applied physics is equally demanding. Application and exploitation of physical law to make useful devices is the most interesting and exciting part, and requires great ingenuity and persistence of effort. What lies behind the phenomenal progress of physics in the last few centuries? Great progress usually accompanies changes in our basic perceptions. First, it was realized that for scientific progress, only qualitative thinking, though no doubt important, is not enough. Quantitative measurement is central to the growth of science, especially physics, because the law of nature happen to be expressible in the precise mathematical equation. The second most important insight was that the basic laws of physics are universal. The same law applies in widely different contexts. Lastly, the strategies of approximation turned out to be very successful. Most observed phenomena in daily life are rather complicated manifestation of the basics law. Scientists recognize the importance of extracting the essential features of the phenomena from its less significant aspects. It is not practical to take into account all the complexities of a phenomena in one go. A good strategist is to focus first on the essential features, discovers the basic principle, and then introduce correction to build a more defined theory of the phenomena. For example, a stone and a feather dropped from the same height did not reach the ground at the same time. The reason is that the spatially or essentially aspects of phenomena, namely free fall under gravity, is complicated by the presence of air resistance. To get the law of free fall under gravity, it is better to create a situation wherein the air resistance is negligible. We can, for example, let the stone and the feather fall through a long evacuated tube. In that case, two objects will fall almost at the same rate, giving the basic law that the acceleration due to gravity is independent of the mass of the object. With the basic law thus found, we can go back to the further introduced correction due to the air resistance, modify the existing theory, and try to build a more realistic theory of objects falling to the earth under gravity. Thank you.